This video is for section 9.2. It's on similar polygons. So what are similar polygons? Two figures that have the same shape, but not necessarily the same size. Those are called similar figures. Now, instead of writing the word similar, you can write this little tilde. That means two things are similar. Two polygons are similar if two things happen. The first thing is the corresponding angles must be congruent. So if you have two triangles, you need 3 pairs of congruent angles. If you got quadrilaterals, you need 4 pairs of congruent angles, so on and so forth. Second thing is the corresponding sides must be proportional. That doesn't mean they're the same length. Proportional means they have the same ratio of lengths. So again, if you have triangles, you have to write 3 ratios of corresponding sides, and those ratios must end up being equal. If you have quadrilaterals, you need 4 ratios that are equal. That's what proportional means. The ratio of the lengths of the corresponding sides, that's called the similarity ratio. So when you write your, let's say you have a triangle, let's say you write your 3 ratios of corresponding sides, and they end up being proportional. That ratio is called the similarity ratio. Sometimes we'll call it the scale factor also. Both are acceptable. So here's our first example. We're going to understand what similarity means. Here's a similarity statement. They're telling you that this 4-sided figure is similar to this 4-sided figure. Now we're going to complete each statement. The measure of angle E is equal to something. If you look at your similarity statement, angle E and angle A are congruent. So the measure of angle E is going to be equal to the measure of angle A. That's what similarity means. The corresponding angles are congruent. So angle E's measure is 53. Now, the other part of similarity talks about the side lengths. These two figures are similar, but if you notice their corresponding side lengths, like segment AB compared with segment EF, they're not the same length. But what they're telling you is they're going to be proportional. So A to B divided by E to F gives you this ratio. Now, whatever that ratio is, it's got to be the same as every other ratio of corresponding sides. So for example, what does segment AD correspond with? Don't just look at the picture and say this is the bottom, so it goes with the bottom. That doesn't always work. We could turn these. Use your diagram, or use your statement. Segment AD corresponds with segment EH. So here's what this means. This ratio, whatever this happens to be, big to little, has to equal this ratio, big to little. Part C asks for the measure of angle B. We know that angle B is congruent to angle F, and angle F is 127 degrees. So that's the measure of angle B, 127. Here's another statement of proportionality for the sides. Segment GH corresponds with segment CD. Notice segment GH corresponds with segment CD. So whatever that ratio is, it better match the ratio of all the other corresponding sides. So segment FG goes with segment BC. FG, BC. Example 2, we're going to determine if two figures are similar. So in the last example, they told you they were similar, and then you said everything that you knew because of that. In this one, they tell you more information than they ask you if they're similar. If they are similar, we're going to write a similarity statement, and we're going to give the similarity ratio. So there's a lot going on in this one, but this is a really, really good problem. For these two figures to be similar, you have to have corresponding angles congruent. Let's check them. I see a 45-degree angle. That matches up with this guy. I see a 60-degree angle. That matches up with that guy. I see a 75-degree angle. And that matches up with this guy. The corresponding angles are congruent. So I'll put a check mark. The second thing you need to check for are the corresponding sides proportional. So that involves writing three ratios. And here's how this goes. I'm going to find the smallest side over here. And if this figure is similar to this figure, the smallest side here is going to go with the smallest side there, and so on and so forth. So my smallest side over here is 16. I know that if these are similar figures, that it has to go with 12, because they're both the smallest sides. The 20 is the next smallest, so that's going to have to go with 15. The 24 is the biggest, so that better match up with 18. Now, these ratios sure look different. They all use different numbers, but that doesn't mean that they don't reduce to the same thing. So you can type this into your calculator just like we did in the last section. Hit math, enter, enter to see if these ratios all equal the same thing. I can't project my calculator for you right now, so what I'm going to do is just reduce these in my head. I know that 4 goes into both of these. 4 goes into here 4 times, and 4 goes into here 3 times. So this guy's 4/3. I know that 5 goes into both of these, 4 times and 3 times. I know that 6 goes into both of these, 4 times and 3 times. And what do you notice? They all end up reducing to 4/3. So what is the similarity ratio? 4/3. Big to little. Now the other thing you need is the similarity statement. I'll change color so we don't get confused. The similarity statement tells you that triangle DEF is similar to triangle, whatever this guy is. Now the order matters. Notice how D is the 60-degree angle, so that better go with C. E is the 75-degree angle, so that's going to go with B. F is the 45-degree angle, so that goes with A. These sides were proportional. I forgot to put the check mark. And the corresponding angles were congruent. That's what made them similar. And your scale factor is 4/3.